সরকারি মহিলা কলেজ কর্তৃক আয়োজিত অনলাইন তথ্য ও যোগাযোগ প্রযুক্তির ক্লাসে সকলকে স্বাগতম। সাতমান সাকিব, প্রভাষক তথ্য ও যোগাযোগ প্রযুক্তি, ঠাকুরগাঁও সরকারি মহিলা কলেজ। আজকের আলোচনার বিষয় ওয়্যারলেস কমিউনিকেশন, ইনফ্রারেড রশ্মি এবং এক্স-রে নিয়ে আজকে আলোচনা করব। ইনফ্রারেড রশ্মির সুবিধা: তুলনামূলকভাবে দামে সস্তা, সীমিত ব্যান্ডউইথ, খুব কম বিদ্যুৎ শক্তির প্রয়োজন হয়।
X-rays and infrared rays. A wave is defined as a motion of disturbance in a medium. Waves such as ocean waves are known as mechanical waves and need a material medium to propagate. However, there are certain waves which do not need a material medium to propagate. These are electromagnetic waves that consist of magnetic and electric fields vibrating at right angles to each other. Energy changes in atoms or electrons produce electromagnetic waves, which are transverse in nature. These waves transfer energy from one place to another. All electromagnetic waves travel at the velocity of light, that is 3 into 10 raised to the power of 8 milliseconds, and can be absorbed by matter. As they do not carry any electric charge, electromagnetic waves cannot be deflected by electric and magnetic fields. They exhibit wave properties such as reflection, refraction, diffraction, etc. X-rays and infrared rays are types of electromagnetic waves and have proven to be very useful to man. However, these rays do not fall under the visible spectrum of light and hence are invisible to man. X-rays were first discovered in 1895 by the German scientist Wilhelm Röntgen. As he did not know what these rays were, he termed them as X-rays. They are also known as Röntgen rays. X-rays are capable of ionizing the gases they pass through and can also produce fluorescence in substances such as zinc sulfide and barium platinocyanide. Their wavelength ranges from 10 to the power of -9 meters to 6 into 10 to the power of -12 meters. X-rays are produced when fast-moving electrons fall on a target of high atomic weight. This is the working principle for the X-ray tube. The X-ray tube, or the modern Coolidge tube, consists of a highly evacuated glass tube containing a cathode and an anode. The cathode consists of a molybdenum metallic cylinder and tungsten filament, while the anode is a copper block within which the target tungsten is embedded. Tungsten is used in the production of X-rays because it has a high melting point and a high atomic weight. It is also a good thermal and electrical conductor. The tungsten filament in the cathode emits electrons when it is heated by a low voltage battery. These highly accelerated electrons are focused by the molybdenum cylinder on the anode by applying a potential difference of about 100,000 volts between the anode and cathode. When the fast-moving electrons strike the target tungsten in the anode, X-ray beams are emitted from the X-ray tube. The intensity of X-rays can be controlled by adjusting the filament current, and the quality of X-rays can be controlled by adjusting the voltage between cathode and anode. As X-rays affect photographic plates, this property is utilized in the X-ray tube. The X-rays strike a photographic plate and can produce, for example, an internal image of the human body. This is possible because X-rays can pass through substances such as glass, wood, and even flesh. Flesh contains lighter elements like hydrogen, carbon, nitrogen, and oxygen, which are all poor absorbers of X-rays. Bones, however, are composed of calcium, an element heavy enough to absorb X-rays. Heavy elements like calcium, gold, and lead are good absorbers of X-rays. X-rays are therefore used in the fields of radiography and radiotherapy to detect fractures, dislocations, foreign bodies embedded in the body, and to treat skin diseases and malignant tumors. However, exposure to a large amount of X-rays can result in sickness or even death. The application of X-rays is not limited to medical science alone. X-rays are used to determine whether a gem is genuine or artificial. X-rays are also used to detect defects in tennis balls, rubber tires, etc. X-rays are used in industries to detect cracks or flaws in metal casts, machinery parts, and in heat treatment and formation of alloys. One of the most innovative uses of X-ray technology has been in the field of forensic science. X-rays are used to detect dangerous or smuggled substances which can be hidden in luggage or on the person himself. This can include explosives, gold, opium, jewels, etc. Very soft X-rays can be used in detecting counterfeit currency and forgery in documents. Electromagnetic radiation with wavelengths longer than that of red light is called infrared radiation. Infrared rays have a wavelength ranging from 10 raised to the power of -3 to 7.8 into 10 raised to the power of -7 meters. Infrared radiation was first discovered by William Herschel in 1800 while measuring the temperature of each color of the spectrum produced when sunlight passes through a prism. Infrared waves are produced by molecules of hot bodies. The sun is a natural source of infrared rays, while fire is an artificial source of infrared rays. The human body gives off infrared radiation, which is felt as body warmth. It has a wavelength of 1/10 to 1/100 millimeters. Although we cannot see infrared rays, certain animals like snakes can. They have special pits on the side of the head which use infrared radiation to detect warm objects such as a mouse in the dark. Such infrared rays are not absorbed by air or thick fog. They can be used to take photographs where visible light does not penetrate. Infrared rays can also be used in night vision cameras, goggles, and binoculars. Infrared rays are used to improve blood circulation, as they help expand blood vessels and are also used to treat muscle and joint pains. Molecular structure can be determined easily using infrared radiation. This is especially useful in the case of organic compounds. A highly useful application of infrared rays is in detection of water sources and forecasting of weather. Infrared satellite pictures show water bodies like seas and oceans black in color. They can also be used to locate diseased crops. X-rays and infrared rays can be applied across a number of fields for the benefit of mankind.
The nucleus of radioactive material emits three different types of radiation rays, called alpha, beta, and gamma. Due to the distinct electrical charge characteristics of the alpha, beta, and gamma rays, they can be separated by directing a beam from a radioactive source through a magnetic field. Alpha rays carry particles originating from the nucleus of a radioactive atom. These particles consist of 2 protons and 2 neutrons. Essentially, they are positively charged helium atoms stripped of their electrons. The magnet causes these particles in the alpha ray to bend in one direction. Beta rays are a stream of negatively charged electrons. After passing through the magnet, they bend in the opposite direction of the alpha ray. Because electrons of the beta ray have less mass than the protons and neutrons in the alpha ray, the beta ray undergoes a more pronounced bend. Gamma rays are pure energy. Because a gamma ray has neither mass nor charge, it remains unaffected by the magnetic field. The unique characteristics of these three types of radiation affect their capacity to penetrate various materials. Whereas an alpha particle is stopped by a sheet of paper, a beta particle easily passes through paper but is stopped by aluminum. A gamma ray is not impeded by the paper nor aluminum, but its progress can be stopped by lead. The degree to which each of these three forms of radiation penetrate human tissue is the basis for limiting a person's exposure to radioactive material. In terms of the impact of radiation on the human body, alpha particles are generally stopped by the outer layer of skin and pose no real harm to underlying tissue. Beta particles, however, are not stopped by the protective layer of skin and can damage deep sensitive tissue. Gamma rays likewise can penetrate deep into the body and cause harm. This is why it is necessary to wear specialized protective gear when working with radioactive materials. When a neutron is fired at high speed into an atom of uranium, it will split the atom in a process called fission. The stability of the nucleus of an atom is maintained by the balance between the repulsive electrical force among protons and the attractive nuclear forces holding the nucleus together. With uranium, this balance is unstable. Thus, when a fast-moving neutron collides with the nucleus of uranium-235, it is stretched into an elongated shape. This elongated shape tips the balance in favor of the repulsive forces, and the uranium-235 atom splits into fragments of krypton, and barium. 3 neutrons are also generated from this powerful release of energy. The 3 forcefully ejected neutrons can each strike an atom of uranium, resulting in the case of an atomic bomb, a catastrophic chain reaction. The nuclear fission process is also the source of energy used to operate nuclear power plants. In a controlled environment, the tremendous heat generated by splitting uranium-235 is used to produce steam that drives turbines to generate electricity.
উইলিয়াম হার্শেল 1800 সালে ইনফ্রারেড আবিষ্কার করেন। এই বিকিরণের ওয়েভলেংথ দৃশ্যমান আলো থেকে বড়, কিন্তু মাইক্রোওয়েভ থেকে ছোট। খালি চোখে এদের দেখা যায় না। চিত্রে অবলোহিত রশ্মির একটি স্থির চিত্র দেখতে পাচ্ছ। ইনফ্রারেড প্রযুক্তির অসুবিধা: অধিক দূরত্বে ডেটা ট্রান্সমিট করতে পারে না। আলোক রশ্মি, ধুলা, বালি ও কুয়াশা ডেটা ট্রান্সমিশনে প্রভাব ফেলতে পারে। এটি ঘরের দেয়াল বা অন্য কোনো বস্তু ভেদ করে অপর প্রান্তে যেতে পারে না। অ্যাপ্লিকেশনস অফ ইনফ্রারেড রে: টিভি, সিডি প্লেয়ার, মিউজিক সিস্টেম সহ যাবতীয় ইলেকট্রনিক যন্ত্রে রিমোট কন্ট্রোলে অবলোহিত রশ্মি ব্যবহৃত হয়।